Okay, lesson 3 for video 2. Now we're going to talk about a second formula called the explicit formula. Now we just talked about the recursive formula, how we can use it to find the next term in a sequence. However, what if we want to find a term way down the line, like the 100th term or the 1000th term? Again, it would be tedious and repetitive to just keep using the recursive formula, so we can use the explicit formula now to do that. So for the explicit formula, you can find the nth term of a sequence. And again, here is the formula. It's a little herky-jerky. We're going to talk about how it connects to a linear equation and then maybe connect it to point-slope form and slope-intercept form that we've used already. But here it is. So a sub n, that's the any term. So any term is equal to the first term, a sub 1, plus n minus 1, n being the term number, and then d is that common difference. Okay, so there we go. All right. So we're going to use this formula, okay? And then we're also going to talk about how we can just use, again, other linear equations to complete these problems. Again, because the chance of you remembering this exact formula for the OST or even our topic 3 test might be slim. Okay, so let's talk about a problem here. Okay, so it says the cost of renting a bicycle is given in the table. How can you represent the rental cost using an explicit formula? Okay, so again, let's go through and talk about the explicit formula. So first of all, we need to find what's called the common difference, right? So we have this common difference d, and the way that we're going to find this common difference d is we're going to look at our table. The number of days rented, these are our term numbers n, 1, 2, 3, 4. The rental cost is going to be our term value, a sub n, right? So the first term is 26. So again, the first term is 26. That's what that means. All right. So we look at our table, and just like we did in 3.2, we're going to find the differences. And you can see that this d is very similar to what we use as the slope. Okay. So we're going to make that connection. So from 1 to 2, we're adding 1. From 2 to 3, we're adding 1. From 3 to 4, we're adding 1. So you can see they're changing by 1s, right? And then from 26 to 38, we're adding 12. 38 to 50, we're adding 12. 50 to 62, we're adding 12. So between each term, we're adding 12. So our common difference d is going to be 12. So if we use the explicit formula, a sub n equals a sub 1 plus, and they do n minus 1 times d. All right, we're going to do a sub n equals, our first term is 26. It's right here in the table. First term is 26. Plus, we're going to leave n alone. N is like our x value, right? This is our y, n is our x. Just like we have, for functions, x and y, and a sub n. And then our common difference d is 12. So this is the explicit formula. But now we can make this look like slope-intercept form. And the way we're going to do that is by distributing the slope, or distribute the common difference. All right, I'll do that right here. So we have a sub n equals 26 plus n times 12 is 12n, and negative 1 times 12 is negative 12. And then we're going to combine our like terms. There are two constant terms, 26 and minus 12. So 26 minus 12 is 14, and then the 12n comes down. So I'm going to put 14 plus 12n. And that would be another way to write this explicit formula. And again, if you look at this format here, this is very similar to y equals mx plus b. Right? The 12, the common difference is your slope, so that's your d. The n is your x, and then 14 is your b. That's your 0th term, a sub 0. They don't give you the 0th term in the table. Typically, when you do a sequence, you start with the first term. So this b value, this 14, is the 0th term. So now, how else can we look at this using previous linear stuff? Well, let's just use point-slope form y minus y1 equals m parenthesis x minus x1. However, what we're going to do here, right, is we need to interpret this a little bit differently. Your y's are the term values. Your x's are the term numbers, and your m is the difference. So our m value, which is the common difference, will be a 12. And your x1, y1 is going to be one of the ordered pairs in your table. Let's just use the first term. So n value of 1 and our a sub n value, which is going to be 26, right? So this is our, I'm sorry, so let's go, this is our n value. One sec. This is your term number, and this is your term value. So we're going to use 1, 26. And I'm going to plug this in to our point slope form. So y minus your y1 is a 26 equals m, which is 12, your common difference, times x minus, and your term number is 1. And now we're going to write this in slope-intercept form by doing 2 steps. Again, the same 2 steps we did in topic 2. We're going to distribute the 12. Y minus 26 equals 12x minus 12. And now we're going to add 26 to get the y by itself. And we get y equals, and this is 12x plus 14. And that is exactly the same thing we got up here. I know I put the 14 first, but it's all the same. And this is your linear equation that represents this same formula. You make the y and a sub n, you make the x and n, and the 14. You'll also see this on the state test. Instead of using a sub n, they'll use f of n. They'll use function notation like we've been doing in 3.2. F of n equals 12n plus 14. So all of this is the exact same thing. So I don't care how you do these problems. Like I said, I don't think you're going to memorize this formula here. But if you do, feel free to use that. I think the rest of the way I'm going to use point slope form because that is a form that you've been taught. And I think it's a cool way to connect this to linear equations. All right, next. What is the cost of renting the bicycle for 10 days? The explicit formula is this. Gives the rental cost for n days. So what they're saying here is we want to find the 10th term, right? Our n value is equal to 10. So we want to find a sub 10, not a sub n. We want to find a sub 10. So what we're going to do is we're going to take our formula and we're going to replace n with 10. So to find a sub 10, we're going to do 14 plus 12 times 10. And this is just evaluating a function. I'll make that 10 better for all those who have trouble reading my writing sometimes. There we go. And you're just going to plug this in Desmos or use your brain, right? So 12 times 10 is 120. 120 plus 14 is 134. And that is the cost for renting the bicycle for 10 days, $134. Again, you could think of this as f of n equals 14 plus 12n. This is a function, and again, they're telling you that n equals 10. So plug in 10 here, plug in 10 here, and you just evaluate this right side like we did. And f of 10 would be 134. So on a graph, if you graph the point 10, 134, it would be on this linear function. Again, trying to do our best to connect it to previous stuff. All right, next. It says, how is the explicit formula of an arithmetic sequence related to a linear function? So again, I think we've been doing this the entire time. So we have an explicit formula for an arithmetic sequence related to a linear function. So this is your formula. Again, I would just think of it as f of n equals 14 plus 12n. I'm actually going to rewrite it as 12n plus 14, putting the variable first. And again, this is just slope-intercept form. Your f of n is y, and you have mx plus b. Again, the n is just your x. So this is going to say y equals, or f of x equals, whatever, or f of x, whatever you want to call it, 12x plus 14. Now, it is a word problem, so I'm going to graph it in the this setup. In this problem here, your x is your n, which is the number of days, right? So we're going to do days. And for this one, we're going to count by ones. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then for our y, it's going to be cost in dollars, right? And I'm going to count this by, I did 20s. So 0, or I'm sorry, by 10. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, right? And if you graph this, right, we start with the b. So your b value is the 14. Go up 14 on the graph. It's somewhere between 10 and 20, not quite halfway, but I'm going to make it right around halfway. And now this guy, your common difference, is the slope, 12 over 1. Now, this could be difficult to kind of determine, 12 over 1. Again, this is at 14, so you have to go up 12. So up 12 from 14. Again, this is odd, so I'm going to do, so 14, when you add 12, that's going to be 26. And that would be 26, and then you have to go to the right one. So from here, go up to 26. Again, count up 14, but go up to 26. Oh, I'm sorry, count up 12. So 26 is right over here, and then over 1. Okay, from 26, add 12 again. That would be 38, and go over to 2. So go up to 38 and over to 2. And there we go. And you can see if we continue the pattern, it would be this linear function right here. Okay. So this is all linear. It's all linear. Common difference is the slope. All right. Next, 2 more problems here. So it says the recursive formula for the height above the ground at the nth step is this formula, where a sub 1 is 7. What explicit formula finds the height above the ground for the nth step? So in this problem, they give us 2 things. They give us the recursive formula, and they give us the first term. So from here, we can pull the following information, right? So we know that our first term is 7. So that gives us an ordered pair, 1, 7, right? Term number, term value. And this 4 right there is the common difference, which is our slope. So if I want to find the explicit formula, let's just do point slope form. Y minus y1 equals m parenthesis x minus x1. Y minus your y1 is 7 equals your m is 4, that common difference, times x minus 1. And we're going to rewrite this in slope intercept form by distributing the slope, the 4. So y minus 7 equals 4x minus 4. And then add 7 to both sides to get y by itself. And your y is 4x plus 3. So this is your slope intercept form equation. So you might be able to write it like this. A sub n equals 4n plus 3, or f of n equals 4n plus 3. All of these mean the exact same thing. And this is how you would find the nth term, the nth height of steps. Again, don't need to memorize another formula. The recursive formula, yes, it's kind of strange with that a sub n minus 1, but that just means the previous term. So don't overcomplicate that. All right, last but not least here. The explicit formula for this is there. What is the recursive formula? So again, the recursive formula has its own setup, right? So to find the next term, a sub n, you take the previous term, a sub n minus 1, and you add the difference. So in this explicit formula, you need to identify the pieces and parts. This 1 is your a sub 1, the first term. Oh, I'm sorry. Hold on. Never mind. I apologize. This is not in explicit formula. So ignore me for a second. So let's go back to the beginning. So recursive formula, right? Same thing. I should not have erased that. A sub n equals a sub n minus 1 plus d. So this right here, this is the explicit formula, but it's in slope intercept form. So this 1 here is actually the 0th term, right? And this 1/2 here is the common difference. I don't really care about the 0th term, right? I care about the common difference. So I just plug that 1/2 in place of d. Now, The issue is that when they ask you for the recursive formula, they also want the first term. All right, so let's talk about that. So how do I find the first term? Well, I know what the 0th term is. It's 1. I'm going to add the common difference to that to get the first term. 1 plus 1/2. 1 is 1 over 1, and we can make 1 over 1 become 2 over 2 by multiplying by 2, top and bottom, and that gives us a common denominator. We add the tops. The top is 3, and the bottom is 2. And this is your first term. So again, I just simply took this 0th term, the y-intercept, if you will, and I added the slope. I added the common difference one time. So when you answer this question, they'll want the first term, which is 3/2, and then they'll want the recursive formula, which is this format, a sub n equals a sub n minus 1 plus the common difference of 1/2. And that's it. So to also find the first term, you can just use this formula, which is what I did, and plug in 1 for n, and 1/2 times 1 would just be 1/2. So that's essentially what I did right there. I just used the explicit formula here, plugging in 1 for n. All right, perfect. So again, don't think of arithmetic sequences as a brand new thing. It is simply an application of linear functions. All right, thanks for watching. See you in class.